Hello, my name is Dmitry Arefiev. I am the lead of the Software Technologies. The goal of today's session is the review of SQLite support in AnyDAC. I will shortly explain what is AnyDAC and SQLite, how to use encryption for SQLite database, how to extend SQLite engine by custom functions, collation and data sources, then advanced SQLite techniques, including callbacks, finally collations. So what is AnyDAC? AnyDAC is a universal data access library for Embarcadero Delphi, C++ builder and free Pascal compiler, with about 50 components. At the moment, AnyDAC offers native drivers for 10 mainstream databases and provides bridge drivers for DBC and DB-Express data sources. What is SQLite? The SQLite is an embedded SQL database engine developed by SQL Consortium. It's a database most widely deployed in the world with rough estimate of 500 million installations. You can find it on all iOS and Android mobile devices, on Mac OS X and Linux desktops. For example, SQLite is used by Firefox, Skype and McAfee antivirus application. To better understand SQLite application areas, let's consider the situations where SQLite is not the best tool. At first, it's high concurrency. SQLite uses reader and writer logs on the entire database file. Although the logs normally are quite short, still with high workload, there will be a contention for the logs. Next, client-server applications. If you have many client programs accessing a common database over a network, you should consider using a client-server database engine instead of SQLite, such as Interbase or Oracle or what else you like. Next, very large databases, let's say several terabytes. And the problem SQLite database is one file database, one operation system file. Now let's build a simple, trivial Delphi database application which will connect to SQLite database and will return order table rows. So I will create new VCL Forms application and I will drop TAD connection component. When I will double click and bring up connection editor, I will choose SQLite as driver ID. Then I will specify SQLite database file name. Then I will set locking mode to normal. This will enable concurrent usage of a DB file by IDE and our test application. Our parameters have default values appropriate for most applications, allowing to get the maximum performance in a single user environment. Now I will press OK. And will try to set connected to true. AnyDAC will show a login dialog. Note it has only password field. It's because SQLite does not have a user concept, and a password is used only when a database is encrypted. So we will just leave password empty and press OK. So yeah, we are connected. Now I will drop TID query. We'll double click. AnyDAC will show query editor dialog. Now I will call query builder. We'll select a table. OK. Test it. Yes. All's fine. OK. And we'll set active to true. Now I will drop tData source. We'll connect it to TID query. Then we'll drop TDB grid and we'll connect it to our data source. To allow our application to work at runtime, I have to drop two additional components which are specific UniDAC components. First is TID GUI-X wait cursor. Another one is AnyDAC physical SQLite driver link. These components assure that the necessary unit will get linked into our application executable. AnyDAC provides compiled SQLite free.obj binary file, which will be linked, embedded into Delphi application, and it will not require any external files like DLL or what else. So now we can run our application. Fine, it works. Now I want to talk about some nice SQLite and AnyDAC features. And I will start from encrypted SQLite database. So to make SQLite database file content confidential and enforce integrity control on the database file, you can use AnyDAC SQLite driver encryption. The encryption support was provided to us by the StreamSec company, who are the experts in encryption. And the support includes AES algorithm with different bitnesses. So to encrypt a database, I have to use TID SQLite security component, and I need to set database to SQLite database file name, then set password and call set password method. So I opened prepared demo application, and we will see how the encryption works. So I set database file name, I set password and call set password method. Then I will use TID connection to connect to our database file. First I will specify database and will not specify a password. And then I will try to set connector to true. We actually should fail to connect. Then I will specify password and will try to connect again. So let's see. Yeah, we got first time error, then we are successfully connected. Want to say that SQLite does not support encryption out of the box. But there are third-party projects providing encryption capabilities. And encrypted database formats are not compatible with each other. That means you cannot use an encrypted database encrypted with non-AnyDAC libraries. If you need that, then you have to decrypt the database with the original tool and encrypt it with AnyDAC. Next SQLite feature is the set of custom extensions, and I will start from custom functions. SQLite does not support a stored procedure or a function concept, as it uses the host language environment to extend the engine functionality. SQLite allows to register the host language functions in SQLite engine and use them in the SQL commands. AnyDAC simplifies this by introducing the TID SQLite function component. So let's see the code. To build a function, a developer has to set function name, argument count, and create onCalculate event handler. As example, I have prepared a function which will calculate the price based using unit price, quantity, and discount. And inside of a function we will multiply unit price and quantity, and then we'll apply discount if it's specified, and we'll return the value. And this is our function usage. Let's see how it works. So this is our total column. Actually, a function may call AnyDAC methods to query a database. SQLite supports also overloaded functions with different number of arguments. And I need to say that SQLite built-in set of the functions is comparably small, and AnyDAC implements and installs to SQLite connection about 50 functions, which are standard de facto for many other databases, and these functions are implemented by the AnyDAC local expression engine. Now we will talk about SQLite custom collations. SQLite stores and handles all character data either in UTF-8 or UTF-16 character encoding. When SQLite needs to compare or sort character data, it must know what rules to use for that, and the rules are known as a collation. SQLite has a few built-in collations, but none of them produces a correct sorting for German, Cyrillic, Arabian, and other languages. And you have to use TID SQLite collation component to build your own collation. And we should set collation name, flags, and set active to true to register a collation with SQLite engine. So let's see how it will work. So I have TID SQLite collation. I set flags to ignore a case, so it will be case insensitive collation. I will assign a name and we'll leave collation kind by default, and that will mean that the collation will be implemented as a standard Win32 Unicode collation. And how to use this collation? You need actually to append collate keyword and specify the collation name. As an example, I have two SQL queries returning 4 strings. And first we will see result set produced using a default binary collation, and then we will see the result set produced using our case insensitive collation. So binary and case insensitive collation. To specify a default collation for a column, you can do this kind of the create table command. There is no ability to specify a default collation for a connection, a database, or a table. And if you do not use a custom collation, then by default SQLite will use a binary sorting order. Next unique feature for SQLite is custom data sources. It's very powerful feature actually. SQLite supports so-called virtual tables. From the perspective of an SQL statement, a virtual table object looks like any other table or view. But behind the scene, queries to a virtual tables invoke callbacks instead of using a DB table. AnyDAC uses Virtual Tables API to implement local SQL feature. The local SQL allows to execute SQLs where the T dataset objects are used instead of the DB tables. A dataset may be as AnyDAC one, as non-AnyDAC one. For example, it may be T-ADO query or what else you like. You can consider local SQL as a native, feature-rich and effective X-query alternative for AnyDAC users. Local SQL may be used in a range of applications, including heterogeneous queries. Their queryable datasets have result sets from different databases. For example, you can mix in single query result sets from Oracle, SQLite, or Interbase, or what else in database. Next is in-memory database. In this case, the TAD mem tables are serving as the data sets, and you will perform queries to these in-memory tables. Then, advanced offline mode. Actually, AnyDAC allows to bring a database connection to offline mode and keep the data sets opened. And with local SQL, an application can perform the local SQL queries. Next possibility is advanced data snap client. There the data delivered by the data snap driver. AnyDAC has actually data snap client driver. And you can use local SQL to perform queries to the delivered data. Next is simplified migration, and you can use the third-party T datasets and use AnyDAC API to work with these data sources while you are migrating to AnyDAC. And finally, data source is not directly supported by AnyDAC. It's actually similar to above, but as a, let's say, persistent solution. Local SQL supports insert, update, and delete SQL commands as transactions and save points. It transforms the corresponding SQL commands into the T-dataset API calls. To support save points, AnyDAC dataset must be in cached updates mode. And for non-AnyDAC datasets, you have to provide an adapter, giving access to cached updates, settings, and other, let's say, dataset features. So let's create a simple in-memory database using TAD mem tables. And the setup will be actually similar for our applications. So I have two TAD mem tables. First call it brands, second call it models. Actually it's about car brands and corresponding car models. So in the code I will define brands ADMEM table structure, then we'll set active to true. This will actually create a memory table, and then we'll append 3 records to brands. Similar I will do with models memory table. Define structure, set active to true, and append records. And you can see that these two in-memory tables are related to each other by the brand code field. So then I will use TAD local SQL component, which is actually AnyDAC local SQL engine. Now I will connect in-memory tables with local SQL engine. Local SQL engine uses actually AnyDAC SQLite connection to register datasets in the connection and to allow to perform SQL queries. So I have a TAD connection which has a driver name equal to SQLite and no more parameters are specified. In this case, AnyDAC will create SQLite in-memory database. It means no external data files will be created and everything will be kept in the memory. So the base setup is finished. In the code also I will activate our connection, then we'll activate our local SQL engine. And by activating that, both our data sets will be registered in that connection. Then I have TAD query, which is linked with our SQLite connection, and it has very simple select command. which will join two tables, in-memory tables by the brand code. So to repeat once again and make it more clear, we have two in-memory tables connected to local SQL. Local SQL is connected to AD connection, and then we may have few AD queries linked to connection, which will actually perform local SQL queries. And I have very simple form. It has page control. First page shows brands, second page shows models, and third page shows query result. So our brands, our models, and the join of these two tables. Next SQLite set of features are the callbacks. And first kind of the callback is update callback. SQLite provides an API allowing to monitor all updates to a database. This feature may be used, for example, to log all updates to a database. To work with this API, a Delphi application should set on update event handler of the SQLite database object, which is actually a database connection wrapping object. So it's kind of a low-level API, internal AnyDAC SQLite driver API. And here we will set event handler in the code, and this event handler will get 4 arguments. First is operation, which will be performed with the database. Then a database name and table name. And third argument is row id. It's actually a unique row identifier identifying the row in the specified table. Next callback is authorization callback. SQLite is an embedded database. That implies that it is a single user database and does not need such concepts as a user, access right, and so on. Still, some application may benefit from an access right control. For example, an application may restrict rights depending on an end-user license. For example, for demo license, less possibilities. For full license, all possibilities. Next possible application is multi-tier data access frameworks, which may use their own user concept, and to control data access rights may use some generic approach. And again, SQLite provides a feature allowing to authorize or not to authorize the SQL commands. To work with this API, Delphi application should set on authorize event handler of SQLite database object, which is again a database connection wrapping object, low-level AnyDAC object. Worth to note that onAuthorize and onUpdate event handlers must be set after connection is activated. And in this authorize callback, application will get operation code and 4 arguments which are operation specific actually. Then callback must return a code which will allow or deny the operation. And in our sample we will deny all delete operations. So now we'll see how this works. So that are our callbacks. So we assign them in the code. When we have query returning order details, table rows, and in this memo we will output the callback calls. So I opened the table and here we see first SQLite asks our application to authorize general select operation. Then SQLite asks to authorize read operation for each column of order details table. And now we will try to delete some record. Yes, we are not authorized. It's actually what our callback is done. Now I will try to modify, and we see again that we are authorized update operation, then read, and finally we see on update event handler was fired. Yeah. So in my speech I have showed several interesting and important AnyDAC SQLite driver features. And I should say there are much more features in SQLite and in AnyDAC, but our time is limited. And SQLite is a very perspective platform for you as database application developer. And we are working to unleash the SQLite power and make it simple to use. So thank you for listening to me. Now I will be happy to answer on your question.
So thank you very much for that presentation of the AnyDAC SQLite driver. If you have any questions for Dmitry, please feel free to put them in right now. I've got only 2 right now. So the first one is, I don't generally associate SQLite with high concurrency because of its file lock strategy for database writes. What are the best practices with AnyDAC for using SQLite in standalone applications that need to use the background threads that access the database?
Let's say we have in our documentation we have few usage cases showing different set of settings allowing to use SQLite for different application kinds. For example, for few concurrent updating processes, you should set locking mode to normal, synchronous to normal, lock weight to true and a few other settings. But really, maybe the key option will be lock weight. You should set to true. Because SQLite actually, when your application tries to update some record, and if this record is already locked by some other application, then your application will wait when the lock will be released. And setting lock weight to true, that will mean that your application will wait. And there is no other possibility to resolve such conflicts with SQLite. Then there is a few concurrent updating threads in the same application. Then we will suggest to set shared cache option to files to minimize locking conflicts. And there is few options to set up transaction isolations. So that will help again to avoid possible transaction conflicts and even deadlocks. Actually, we have, as I already said, we have about 10 usage cases, most important for most developers, and you can find them in our online documentation. So that's the answer.
Okay, great. Thank you, Dmitry, for that answer. Does AnyDAC work with Microsoft SQL compact files, SDF files?
No, answer is no, because Microsoft do not provide a DBC driver for Microsoft SQL Compact, and they are providing Ado.NET provider and OLEDB provider. And AnyDAC does not support OLEDB. And the reason for that is OLEDB is not cross-platform technology, and it's actually will be supported in the very close future. It's not my words, it's Microsoft words. So yeah, that's the answer. But still, you can work with Microsoft SQL Server Compact Edition using some third-party solutions like DB Express drivers. Yes.
Okay, great. So with that, we have no more questions. People are saying very good presentation. Thank you very much for that presentation. So thanks.
You're welcome.